All right, you guys, this is part 1 of your Topic 2 review video, and in this part we are going to review the general geometry sections over 2.1 through 2.4, in which you will have 16 total questions. Every review problem is going to come from your workbook. So let's start with Topic 2.1 on page 70 of your workbook. We're going to look at the Do You Know How section, and we're going to start at number 5. This Do You Know How section gives us two parallel lines. We know that they're parallel from these little arrows here, and they are cut by a transversal. We want to classify how these angles are related, talk about their measures, and then give the postulate or the theorem that justifies this. So right now we're going to look at angle 2 and angle 6. And we're going to use the theorems and the postulates that we have learned about to name this pair of angles and talk about their measures. If I'm looking at my theorems, I can see that they both are on the same side of the transversal in what looks like the same position of each of the parallel lines. That means that they are corresponding angles. And I'm just going to abbreviate that. They are corresponding angles. And we learn in the corresponding angles theorem that corresponding angles are congruent if the lines are parallel. So we can state that angle 2 is congruent to angle 6. All right, we're in our next example. We're going to do number 7, and it tells us that if the measure of angle 1 is 71 degrees, find the measure of each angle, and we're going to just right now find angle 5. So we want to think, how are angle 5 and angle 1 related? So how is angle 1 related to angle 5? What can you guys see here? They're also corresponding angles, and as we just learned, corresponding angles are congruent. So we can say that angle 5 is actually congruent to angle 1, and therefore the measure of angle 5 is also 71 degrees. There's also several other theorems that we learned about. We learned about alternate exterior angles, or alternate interior angles, and same side interior angles. If we were looking at same side interior angles, that would be angles like 3 and 5. They're on the same side of the transversal, and they are inside the parallel lines. So we learned that same side interior angles add up to be 180 degrees. So the measure of angle 3 plus the measure of angle 5 equals 180 degrees. And there's just a quick review of 2.1. That was all of our angle relationships. Review all 4 of those angle relationships. Now flip to page 78 and let's dive in to section 2.2, which pretty much just is the converse of 2.1. It's saying, well, if we know the angle relationships, we can prove that the lines are parallel. So let's look at that Do You Know How section, and let's look at number 5. We have a figure here of 4 lines, and number 5 is telling us if angle 1 is congruent to angle 2, which theorem proves that line C is parallel, to line D. So first we have to figure out how angle 1 and 2 are related. So one thing I like to do is just break them down. Angle 1 happens at the intersection of line B and line C. Angle 2 happens at the intersection of line B and line D. Which line is the same for both angles? Line B. So that means line B is our transversal. So B is the transversal that cuts line C and line D. So now we know we're not even looking at line A. Like, we could literally get rid of it. We don't need it right now for what we're looking at. And now we want to figure out how are angle 1 and angle 2 connected. And if we look, they're both on the inside of the parallel lines, so they would be interior and they're on opposite sides of the transversal. So these would be alternate interior angles. And the converse of the alternate interior angles theorem tells us that if alternate interior angles are congruent, then the lines are parallel. So the theorem that proves this is the converse of the alternate interior angles theorem. We do have to state that it's the converse that proves that the lines are parallel, because when we're proving lines are parallel, we're talking about the converse of those angle relationship theorems. Let's look at number 6. It says, now I do need that other line, so I'm going to undo that. It says that if the measure of angle 2 equals 4x minus 6, and the measure of angle 3 equals 2x plus 18, for what value of x is A parallel to B? So now let's look. We're talking about angle 2 and angle 3. So angle 2 and angle 3. Angle 2 happens at the intersection of lines D and line B. Angle 3 happens at the intersection of line D and line A. So that tells us that line D is our transversal, and then our potential parallel lines are A and B. So the one we don't even need to look at right now is line C. Like, we don't need that. So we said that D was the transversal, and we're trying to prove is A parallel to B. So now we look at those parallel lines, which are A and B, and I can see that angle 3 is on the outside, angle 2 is on the outside, so that's exterior. They're on opposite sides of that transversal, so that would be alternate exterior angles. And we want to know, the only way we can prove that these lines are parallel is if alternate exterior angles are congruent. So we need angle 2 to be congruent to angle 3 for A to be parallel to B. So now we need to do that little bit of algebra to find the value of x that will make those congruent. We know angle 2 is 4x minus 6. We need that to be equal to 2x plus 18. And now we can go through and we can solve that to find that value of x that will make these congruent. And if I solve for x, I end up with x equals 12. So that means x has to be 12 for A to be parallel to B, because we need angle 2 and angle 3 to be congruent and equal to each other. That was section 2.2. Now let's flip to page 90 and do a quick review of 2.3. 2.3 was when we learned that the 3 angles in a triangle add to be 180 degrees. So this is going to be a question like one on your test, where you're given several figures and you're asked to solve for missing pieces. And the easiest way that I like to teach you guys how to do this is start by just filling in what you can, like missing pieces. So right now I don't know x, but I can see that x is connected to this line that is connected to this triangle. So if I can find that missing angle, I can know what it is, and that'll help me find x, because x and that missing angle lie on the same line, and I know that they'll have to equal 180 degrees. So I'm just going to call this question mark, and I know that question mark plus 45 plus 66 has to add up to be 180 degrees. So if we do that math, let's solve for that question mark. If we subtract, okay, that unknown angle is 69 degrees. We can actually label that now. And now I can 100% find x, because x plus 69 has to equal 180 degrees because they lie on the same line. So if I do that subtraction, x has to equal 111 degrees, which if you look, that's what those two angles added up to be, and that's what one of the theorems we learned in this section is, that the exterior angle is equal to the sum of the two interior angles. All right, let's keep going. We've found x. Now let's work towards finding y or z. So if I'm looking at this triangle that y is in, I know this is 30 degrees. I don't know y, and I don't know this missing angle that I'm going to draw with a star, but I can find it because I know that 66 plus whatever that star is has to equal 180. So that means that missing angle must be 114 degrees. So now I can replace that. And since I know these two angles, I can find that one. So 114 plus 30 plus y has to equal 180. And that is 144 plus y equals 180. Y has to be 36 degrees. So now we know y. And our very last thing we don't know is z. Z is a part of this triangle here. And we're given this exterior angle. And from one of the theorems we learned that the exterior angle is equal to the sum of the two opposite interior angles. So we can set that up because this z plus this 43, they're not congruent. I'm going to undo those lines. But they should add to equal 119. So if I do 119 minus 43, I get my answer of 76. So z has to equal 76 degrees. And section 2.3 is all about using this knowledge to find missing pieces. Our last section was section 2.4, which you can turn to page 94 of your workbook. And it was about parallel and perpendicular lines. We learned that parallel lines have the same slope, exactly the same, and perpendicular lines have what we call opposite reciprocal slopes, and they multiply to be -1. So opposite reciprocal means truly opposite signs, one positive, one negative, and reciprocal means we flip that fraction. So an example could be positive 3 over 2 and negative 2 over 3. Opposite signs, one's positive, one's negative, and reciprocals are flipped fractions. So when we want to know if things are parallel or perpendicular, we just need to find their slopes. So let's look at number 7, and we're going to find the slopes of line J and M because that's how we'll know if they're parallel. So we're looking at lines J. I just need to find 2 points on the line to be able to find the slope. So here's one, and here's another. Let's find that slope. Let's count. We go up 1 over how many? 1, 2, 3, 4. So that slope is up 1 over 4. That slope is 1/4. Let's find a slope for line M. This is a point on line M, even though it doesn't look like it, it is. And this is a point, it goes up 1. Okay. So they both go up 1. How many does it go over? 1, 2, 3, 4. Oh, it goes over 5. Its slope is 1/5. So are those lines parallel? They have to be exactly the same to be parallel. No, they're not exactly the same. They're not parallel. Let's look and see, are lines H and J perpendicular? Which we already know the slope of J is 1/4. We already did that. So let's find H. Find a point on H. Here's one. Find another. There's one. All right. So it goes down 1, 2, 3, 4. So H goes down 4 over over 1. So that's negative 4 over 1. So let's look at that. Are those perpendicular, which means are they opposite reciprocals that multiply to be negative 1? I do believe they are. Open up that calculator and check. Is 1/4 times negative 4 1? Yes, it is. So yes, these are perpendicular. The last part of section 2.4 was writing the equation of a line that is either parallel or perpendicular to a given line. And we used our y equals mx plus b slope-intercept form to do that. And it gives us the line y equals negative x plus 7. We have to pick out the slope. And it's always that number in front of the x. So that means here the slope is negative 1. And then they give us an x and a y value, so we can actually find that b value. Y is negative 2 equals our m of negative 1 times our x of 7 plus b. Let's solve. We end up with negative 2 equals negative 7 plus b. We add 7 to both sides, and we end up with 5 equals b. So we can write that equation of the line when we substitute those pieces in, and it would be y equals negative x plus 5, because 5 is our b and our slope is negative 1. If it was perpendicular, we would just do the opposite reciprocal. All right, that is your review of the 4 lessons in topic 1. Watch the next video to review, I meant topic 2. Watch the next video to review proofs of topic 2.